Webinar. My name is Lalith Liyanage. Today is the United Nations World Water Day. This year's theme for the World Water Day is Valuing Water. In line with the United Nations Sustainable Development Goal 6, providing sanitation and water to all by 2030, WSP is committed to assisting communities to have resilient water supply and sanitation infrastructure. With that background, I'm very happy to present today's topic, When the Rivers Stop Flowing. Before I start the presentation today, I would like to remind a couple of housekeeping items. PDF of this presentation is available in the handout box of the GoToWebinar site. And there will be a question and answer session at the end of the presentation. Please keep writing your questions in the box provided during the presentation. Agenda for today's presentation include an introduction to source water resiliency, some resiliency planning considerations, a case study, a brief summary followed by question and answer session. Whether the water source is a lake, river, or well water, there are many vulnerabilities exist in any given water source. These vulnerabilities include extended droughts, sudden water quality changes due to weather, man-made reasons, or natural animal reasons, industrial discharges such as hydrocarbons and other chemicals, accidental spills including train derailment, trucks accidents resulting in various compounds released into the water source, pipeline ruptures, human errors, fire, floods, and terrorist activities. Let's take a look at a couple of past incidences. First incident we are talking about today happens in 2016 in this community is city of Prince Albert in the province of Saskatchewan, Canada. They were serving the population about 36,000 people. Water for this community is taken from the Saskatchewan River. In July that year, approximately 200 to 250,000 liters of heavy oil and diluent was accidentally released into the river. When the spill was detected based on the river water velocity, it was estimated that oil water will reach the water intake in about 4 days. Like many communities, Prince Albert had no planning for an incident like this. As a result, a state of emergency was declared to deal with the situation. Very quick actions has to be taken to provide emergency water storage and supplying water from number of alternative sources. Second incident we are going to talk about the 1993 Milwaukee, Wisconsin. This is one of the most documented waterborne disease outbreaks in the United States. This particular water system is serving about 800,000 people. The source for this water supply system is the Lake Michigan. There are 2 lake intakes. In March 1993, about 400,000 people got infected with the diarrheal infections as a result of waterborne contamination. And among many reasons, one of the key finding of the investigation is that the high turbidity spikes that occurred in the intake due to heavy rain events was responsible for this incident. As I mentioned, one of the one of the key root cause was the raw water spike in the intake. This particular graph that I shows here on the right side scale, the diarrheal infections rates per 100,000 people detected. And the right side shows the turbidity of the treated water. As you can see, the treated water turbidity was much lower, approximately less than 1 NTU. However, in around March, this turbidity spike happens, and then followed by the large number of gastrointestinal outbreaks, and then the actual outbreak was announced in somewhere in April. And the case study we are going to look at later on today is actually related to something similar, potential turbidity spikes occurring in intakes, and then what are some of the solutions for that. Above incidences and many other reported incidences clearly indicate that there's a need to have a source water resiliency plan in place for any given community. Even though many of these incidences cannot be predicted, um, there's quite a bit of planning and preparations can be done to assist with the to face this type of incidents when it happens. Let's look at the key planning tools available for any community that include waterworks emergency plans, drinking water safety plans, climate change adaptation plans, and source water resiliency planning. Depending on your location and the regulatory environment, some of these planning may be mandatory. For example, in the province I live, Waterworks Emergency Response Plan and the Drinking Water Safety Plans is mandatory. At this point, I want to give you differences in focus in each of these planning tools. For example, Waterworks Emergency Response Plans, the main focus is to face major emergencies. They are generally beyond the waterworks and cover the entire community, and how to get back to normalcy as quickly as possible. So the focus is just facing those major emergencies. Drinking water safety plans is an adaptation from the World Health Organization drinking water safety for the developing world. The primary focus is the microbiological safety of the drinking water. When it comes to the climate change adaptation plans, the focus is again to develop the adaptation plans for the infrastructure to face these long-term, slowly changing climate conditions. So all these waterworks emergency plans, drinking water safety plans, and climate change adaptation plans will have an overlap with the source water resiliency planning. However, source water resiliency planning exclusively deal with the resiliency of the source water source and coming up with a plan to have a plan for the community to deal with an incidents like that we mentioned before. So source water resiliency can be defined as the ability of a source water system exposed to hazards to resist, absorb, accommodate, and recover from the effects of hazard in a timely and efficient manner. So, and that will be the focus of the source water resiliency planning. Let's look at key planning considerations in developing a source water resiliency plan. The first of all, establishing a vision and identifying stakeholders for the particular community. So every community have unique characteristics with respect to the stakeholders, and also what do you want to make sure in an incident and also before an incident happens. And characterizing the source and watershed, there's a misconception that we know our watershed, but if you really look at closely at the watershed, you may find so many vulnerabilities that we have not seen before. And through that characterization, identify hazards, and then assessing and prioritizing risk. Anybody who has involved with any planning exercise would know that assessing and prioritizing risks with respect to identifying the probability and estimating the consequences and coming up with the risk score so that you can prioritize which risks are the highest. And after that, we can develop an action plan with the objective of both providing clean and safe water in a sufficient quantity under normal conditions, and also maintain essential quantity under emergencies where capability of the system is impacted. Like any other plan, regular review of the planning is also required. As I indicated earlier, watershed characterization and identification of all potential hazards is a very important aspect of the planning process. Contaminant sources may include the human footprint, just the density of the population and sewer discharges, for example, and other municipal, agricultural, and industrial discharges, and transportation activities and pipeline. This particular figure shows the hazardous material transport corridor for the city of Edmonton, where I live. As you can see, this hazardous material transportation corridor actually crosses the river and a bridge where we take the water for drinking water from this particular river. And if any accident to occur in this bridge containing hazardous material, it will contaminate the river. Not only that, One of our key water treatment plants intake is actually very close to this bridge, and within very short time, the intake will be impacted. And continuing on this, the watershed characterization, this figure shows all the pipelines within my watershed, where all these different materials like crude oil, fuel gas, natural gas, sour gas, and every other components being transported. One good thing about this digital age is that this information is actually readily available from websites of your regulatory agencies and other interest groups. It is important to consider these possible accidents, and when and if these incidents happen, what type of contaminant are you expecting at the intake, and what kind of concentration, what level of concentration will be expected at the water treatment plant? Can the existing treatment handle this type of contamination? And what enhancements can be done to improve the treatment during this type of contamination? And do we need to bring in some standalone systems or portable systems? And also, as part of the planning process, it is quite important to do bench scale and pilot tests to simulate or mimic the accident situations and see how the treatment plant will react or respond. Alternative water supply evaluation. In case the water supply is compromised, what other sources are available nearby so that we can get the water during an emergency? And again, considering the upstream monitoring so that you can get some early warning is very important aspects of the planning process. Once we have an idea about possible hazards that can happen, several planning investigations can be done, including intake protection options evaluation, emergency storage options evaluation. What are the emergency need? Like in an emergency, you may not need the full amount of water that you generally supply. What are the critical needs of the community, and who gets the priority and how much? Those things are very important questions to answer during the planning process. And also emergency treatment may not necessarily be the same as your regular treatment, and what are the options? That's where you may have to work with some of your regulators to address those issues, and sometime only may need operational changes to deal with this situation. And not only the treatment plant and the intake, how also need to think about the distribution system. It may be contaminated, and how can we isolate them? And in case it's completely not available, can we bottle the water from the treatment plant and distribute to the key people? One of the key answers we need in planning to deal with an emergency is to know how much water is enough during an emergency. You can get some guidance from various agencies if you looked into in the websites. And this one is from the Federal Emergency Management Agency of US, and then they recommend about a 1 gallon or about 3.8 liters per person per day as the minimum required for sustenance. Let's look at the case study now. Comox Valley, it's in the east coast of Vancouver Island in British Columbia, Canada. The water treatment facility serves approximately 40,000 people, including city of Courtenay, town of Comox, and Comox First Nation. Water intake is located in the Comox Lake, as you can see here. That's a narrow, long, beautiful lake. Historically, occasional high turbidity spikes have been observed in raw water, particularly in 2014 and 2015 years. These high turbidity spikes were partly a result of erosion, as you can see in the picture below here, in some of the tributaries which are feeding the lake, and especially during heavy rain events. As a consequence of these high turbidity spikes, frequent boil water notices were issued, impacting the population and the businesses. As per the provincial regulations, because of the historically low turbidity of the Comox Lake, there were exemptions for the filtration requirement for the treatment. However, due to these high turbidity spikes, regulators also revoked the filtration exemption, and then they were asked to provide filtration. uh, to deal with these heavy turbidity spikes. And for example, in 2015, there were 47 days the boil water advisories were issued as a result of these high turbidity spikes. WSP has been working with the Comox Valley regional districts for a number of years in planning, design, and implementation of a robust water treatment program, including addressing turbidity spikes and resiliency. Long-term solutions for provide resilient water system included a new deep water intake from Comox Lake, new raw water pump station, new direct filtration plant with chlorine and UV disinfection, and a new transmission main to be connected to the existing system. As you can see in this map, just to get an idea of the relative locations of the facilities, this is the deep water intake, and then the marine pipeline bringing the water into intake pump station and then pumping the raw water into the treatment facility, and then new transmission main connecting to the existing distribution system. While long-term solution is being implemented, number of interim solutions were implemented, including installation of temporary UV disinfection system. This was implemented by simply replacing the existing magnetic flow meter with this new UV unit. Instead of the magnetic flow meter, ultrasonic flow meters were installed to measure the flow rate. And also this UV system was designed so that this can be relocated and reused in the new water treatment plant. So this was a quick and interim solution that had significant effects on the improving the resiliency of the intake system. And in addition, there were operating conditions will also change as an interim solution. For example, if the turbidity of the water is less than 1, utilizing the UV system, a calculated dose of UV was provided to meet the disinfection targets. However, if the turbidity is greater than 1 NTU and less than 3 NTU, UV system was operated at 100% power. If you recall that this system is designed for the future requirements, so this is that will provide significantly more UV disinfection than normally required. And then, of course, if the turbidity still go up and higher than 3 NTU, the boil water notices will be issued while the UV system is in fully operation. So by implementing above interim solutions, the plant was able to reduce 80% of the boil water notices. As you can see here, without that interim UV solution, all these the boil water notices would have been issued at above 1 NTU, resulting in all these points resulting in boil water notices. However, with the UV implementation and working with the regulators, we were able to increase the trigger level to 3 NTU, thereby we can reduce about 80% of the boil water notices otherwise would have to issue. One of the long-term solutions was to provide a deep water intake, which is not subjected to the high turbidity spikes that we observed before. And there were a number of other advantages of that intake, including the more resiliency during drought years and minimizing potential other contamination, providing infrastructure independence, and overall providing more consistent water quality. This figure shows a profile of the deep water intake line. You can see the water intake line is here, and then the marine pipeline and crossing the existing lagoon to get the water into the intake pump station. Let's look at the where the project are at this point. Currently, CVRD is actually implementing the long-term solution. As you can see in the picture here, the marine pipe is being installed. And the picture down here shows that the backwash pumps for the filtration facility is being installed. Let's look at the summary. So it is important to know your watershed, and possible point sources and non-point sources, hazards and pollutions, and possible accidents, and in what emergency quantities you need for your particular community. What are the alternative sources available when your normal source is not available, and what source monitoring and predictions and modeling, for example, and early warning can be installed to get an early warning for possible accidents and other spikes. And what are the alternate treatment options during an emergency and alternate operation procedures. In general, have a plan, have a sourcewell resiliency plan in place. And this must be in place before an incident occur. Based on our first-hand experience, it is very expensive and difficult to respond to something like this if you didn't have a plan in place before. And also, not only a plan in place, but also training for all the staff involved is essential. And also having these plans reviewed regularly is also critical for the long-term success. And at this point, I'd like to remind you there are a number of webinars coming up. As I mentioned earlier, this is the Global the Water Day, and so please consider joining some of these webinars. Thank you for participating, and now let's go to questions and answers.
Thank you, Lalith, for your presentation. So before moving into the Q&A period, I would like to remind attendees to enter your questions in the question box on the GoToWebinar platform. And also you can download a PDF version of the presentation from the handout box on the dashboard. We'll move to the first question. In the event of a hydrocarbon spill, what type of treatment modification can be implemented at a water treatment plant?
Yeah, it is a good question, Sharon. It depends on what type of treatment you have at the current treatment facility. For example, in our part of the world, there are activated carbon, for example, powdered activated carbon we use seasonally to control the odor and taste. So this type of seasonal addition can be implemented very quickly because the facilities are already available in an hydrocarbon emergency, for example, to remove some of the trace compounds. And in some facilities, they may have dissolved air flotation as a treatment technology. And these type of technologies can be enhanced by, for example, increasing the air feed rate during an emergency or a contamination event. There are many opportunities if you look at closely of your treatment system and the expected contaminations. And also at this point, I'd like to remind that doing pilot and bench scale tests, simulating those possible scenarios are also important to identify some of those possible treatment options.
Thank you. Next question. How do you predict the time of a contaminant such as an accidental release to reach the water treatment plant intake?
Yeah, there are, again, fortunately in this digital age, there are a number of models and the software is available, so you can utilize to the model these contaminants. Particularly conservative estimates can be made quite easily. And also if you know the characteristics, for example, river or the lake, there are some estimates can be done based on first principles utilizing, for example, Excel. Because the uncertainties associated with these estimates, you don't have to be very accurate for these predictions. Reasonable predictions will give you enough information to plan sufficiently, and that will help you a lot during an emergency.
Thank you. There's a question related to the case study. Why was the UV system installed at the intake of the system and not in the outgoing water?
Yeah, that's a good question, actually. Remember, this is an interim solution. So we wanted to, in the long-term solution, when the new water treatment plant is installed, the UV disinfection will be downstream of the filtration process, in the outgoing. However, right now, at this point, there are no filtration. There's only chlorination because of the high quality water historically we had. So this location was selected because of the easy implementation at the quickly as an interim solution.
Thank you. There's a question from Christchurch, New Zealand. Do we need a source water response plan for every source? In Christchurch, there are a lot of aquifers, so would
Mhm.
they each need their own plan?
Generally, yes, because I mean, if they are in the same watershed, most of these characteristics will be similar. However, there are always some unique or specific hazards associated with each source. So at least, if they identify, if they take that into account, as a community or a water supply, you can have a one source for resiliency plan. But however, we have to respect that each one of the sources may have unique hazards associated with it. And then, as long as they have taken into account.
Thank you. Next question. Was on-site validation conducted for the UV reactor to determine the turbidity, operation range, and dosage?
Yeah, so right now we have this particular project is delivered as a design build project. So there is a, significant um, uh, opportunities for the contractors to be innovative. However, with respect to performance and regulatory requirement, we have specified that the factory validations are accepted in this provincial regulations. So, and we have specified those requirements and the expected performance under turbidity and UV transmittance conditions that we have clearly specified, covering those ranges. They have to meet the validation, but they can conduct the validation in the factory, not on site.
Thank you. Next question. How can water system be made resilient towards evolving contaminants like microplastics?
Yes, microplastic. Yeah, it's an emerging concerns, and I mean, I totally understand it is a major concern. Right now, as we all know, the regulations are not up to date with the contaminants of emerging concerns, including the microplastic, microfiber, and other a whole range of contaminants. There are good news is that many of the treatments that we provide in drinking water treatments can be changed or can be enhanced to remove these things. For example, the dissolved air flotation, if you are utilizing that, can be improved, enhanced to remove some of this microplastic. And if you are utilizing membrane filtration at your plant, for example, they can be a very effective barrier against the microplastic. And for other contaminants, for example, advanced oxidation, reverse osmosis, these type of technologies have shown to be very effective in removing, these contaminants of emerging concerns, including microplastics. So, in case by case basis, you have to look into the plant that you have and what modifications and enhancements can be done to increase the removal. But something to keep in mind that when we are doing these changes to manage these contaminants of emerging concerns, you have to make sure that the microbiological hazards and others are not compromised, because those risks from the microbiological hazards and others are very high compared to the contaminants of emerging concerns. I'm not downplaying them; they are hazardous and they are a risk too. But you should not compromise the management of those microbiological risks.
Thank you. We'll take the last question. Can risk management be considered as a tool to develop source water resilience plans?
Absolutely. Those tools are that we use for any other planning processes to identify risks and identify the probabilities of the occurrence or the chances of occurrence and the consequences if that happens, and then follow a systematic process and coming up with the risk score, and then that way you can prioritize which risks at the highest score, and then plan. And absolutely, it is an essential tool in source water resiliency planning as well.
Thank you. So we're at the end of our webinar session. Thank you very much for joining today. We look forward to seeing you in our upcoming Snackerlearn webinars on valuing water. Please feel free to follow up directly with Lalith via the contact details shown on the screen. And thank you, Lalith, for a great presentation.
Yeah, thank you, Sharon. Thank you, everyone, for participating in the webinar.
Thank you. Have a wonderful day, everyone.
Yeah.